morning, it's very clear that we live in a world of data, right? And it's even becoming even more so. There's lots of new technologies that are coming about that we haven't even yet begun to think about that is going to all be transmitting data, and we're going to need to process it and store it. So basically, this cover slide kind of has a quick outline of exactly what that is. All of these devices, all being connected, all expanding data, all needing data processing in real time, and how are you able to compute, analyze, retrieve, and store all these elements in a very fast and efficient manner. And that's where Mellanox comes in. So we provide a complete end-to-end interconnect with speeds up to 56 gigabits per second per port, a complete line of adapters, switches, gateways, cables. We announced 100 gig at ISC this year, and you can expect end-to-end 100 gig either at the end of this year or early next. Both on InfiniBand and Ethernet, all supporting RDMA. Whether it's native InfiniBand verbs or if it's RoCE V2, which is the latest RDMA converted Ethernet spec from the IVTA that provides scalable L3 transport. So, in terms of how things are happening today, scale-out architectures are really the only efficient solution for large scale-out deployments. With today's ever-increasing data sizes, a scale-up system just can't strive. In addition, today's applications are relying on scale-out architectures. Applications such as Hadoop and NoSQL databases are by definition expecting this kind of architecture. With applications such as software-defined storage, the network is imperative for scalable performance, as well as for data resiliency and availability. So in terms of RDMA, how does it work? Right? So with traditional TCP/IP, all the network operations are being handled by the CPU. With RDMA, we can offload that so you can get your efficiency all the way up to, we say, 88%. We've seen cases where it can get up to the theoretical limit, both on Ethernet and InfiniBand. So to help accelerate MapReduce, we collaborate with Auburn University to create UDA, which is an unstructured data accelerator. It's a plugin that's fully integrated into the Apache Hadoop framework, and from there it's in the other distributions. So when you see the performance benchmark here, we used a 1 terabyte TeraSort. We see 2x performance increase. So just by adding UDA, and this is just using Mellanox FDR and InfiniBand, just by adding UDA on top, we're able to increase performance by 2x. The plugin code, as well as the UDA package itself, is open source and can be downloaded from the Google Code repository. For in-memory analytics, we worked with Tachyon with something that we call Excelio, which is essentially a wrapper that we put on top of it to be able to enable C applications to realize RDMA performance. We even have a wrapper for Java, so folks that are porting to Spark can realize this type of performance. And based upon what's running on top of it, we can see throughput performance from 34 to 62%. So beyond that, there was some talk about HDFS. Here, GPFS is integrated in IBM's Big Insights. When you compare the two, we can see that GPFS has better I/O over HDFS, anywhere from a 35% increase on the throughput, the write, up to 50% on the read. So using our Mellanox messaging accelerator, we can we can do a 4x increase in terms of more users per server. So query performance here is pretty critical, especially for web-based applications, because as more users come on, there can be denial of service. So by enabling the accelerator here, you can be installed on both the client and the server, which these graphs show has happened. And there's no change to the application that's needed to support it. The package is completely open source and is part of the OFED driver. I feel like I skipped a slide. Okay, so with Pivotal, about a year and a half ago, we worked with them to put together a 1,000-node Hadoop analytic platform. This is using our ConnectX-30 and SwitchX technology, which we call Virtual Protocol Interconnect, which allows you to run InfiniBand as well as Ethernet on the same network. It's really easy to switch over from InfiniBand to Ethernet. It's just a command line that you have to execute. It switches over fairly seamlessly. There's some information exactly how Pivotal did that. But what's important about this is that it's completely open to the Hadoop developer community. So anyone can log in and test run their applications to see the performance, whether they're trying to test on RDMA or just kind of see what things are going to be looking like on a high bandwidth interconnect, whether it's Ethernet or InfiniBand. And all you have to do is just kind of show a proof case of why you're going to use it and how's it going to help Hadoop. And it's free and accessible to all. And that's really it. I mean, a network, in order to be able to provide a really good big data solution, you are going to need a high bandwidth interconnect. We're starting to see a lot of different ISVs porting to RDMA, and if you haven't already, we'd love to be able to help you with this. We've provided various software applications that allow you to do it fairly seamlessly. Obviously, how complex the application will determine the time it will take to make that happen. We're really accustomed to doing high-performance computing clusters. We have a lot of systems out there with 10,000 or more nodes, and we'd love to work with you. And that's it.